think about a machine. Not a fancy one, just something solid, like a good engine. Now imagine that machine is the Earth. I'm part of it, one cold, slow-moving, but powerful part. It's the system of frozen water. That's the cryosphere. The cryosphere includes every bit of frozen water on the planet. Ice sheets, glaciers, sea ice, frozen soil, snowpacks, literally all of it. Whether it's a patch of ice in your backyard or the thick layers covering Antarctica, it all counts. The real focus here isn't just where the ice is, it's what the ice is doing. Cryospheric processes are what scientists call the changes that happen to frozen water. When it melts, moves, cracks, builds up, or disappears, it's all part of it. Some of the changes are small, like a patch of snow refreezing overnight. Others are kind of big, like a glacier breaking apart and sliding into the ocean. Two of the biggest actions in the system are called accumulation and ablation. Accumulation is when snow and ice build up over time. Ablation is the opposite, when they melt or break off. That back and forth decides whether glaciers grow or shrink. For example, Greenland's interior adds snow every single year. That's accumulation. But at the edges, more ice breaks away. That's ablation. And overall, Greenland is losing some of that glacier space. And the shifts, they're not even. A glacier might add 10 feet or 3 meters of ice in winter and lose 15 or 4.6 meters by summer. Sometimes it looks stable on top, but it melts from the bottom. Permafrost. Frozen ground deep under the surface that can stay solid for thousands of years. Then you could have one unusually warm summer, and it all buckles. And that collapse, it can release gas that's been locked in there since before recorded history. The size of these systems is very hard to imagine. Antarctica alone holds about 6.4 million cubic miles, or 26.5 million cubic kilometers of ice. That's enough to raise global sea levels by over 190 feet, or 58 meters, if everything melted. But we don't need a full meltdown to feel it. Since the early 90s, sea levels have been rising. It's really not a lot, though, like about 3 millimeters per year, so about 1.3 inches per decade. And most of that does come from melting ice. But it's not just for the oceans. Ice reshapes land, too. You see, glaciers, they cut deep valleys. They drag rocks and leave behind massive ridges and basins. Some of the fastest ones in Alaska, they can move up to 100 feet, or 30.5 meters a day during a surge. And that's like watching a mountain crawl. And there's history here. About 15,000 years ago, a giant ice dam near Lake Missoula in what's now Montana, it all held back a flood. It trapped over 500 cubic miles, or 2,100 cubic kilometers of water. When the ice broke, the lake emptied in 2 days, and that flood tore through parts of Northwest, and it carved out entire sections of the Columbia River Gorge. Geologists still talk about it as one of the largest floods ever recorded, and it all started with a single shift in ice. We still see those kinds of effects today, just on a much smaller scale. In northern Canada, roads bend and crack as the permafrost underneath thaws. In Russia, the city of Norilsk was built on frozen ground until that ground started to soften. And the buildings that stood for generations, they started to tilt and began to break. The word cryosphere, it comes from the Greek word cryos, or krios. That's the actual proper way to say it. And it means cold. It's not just a scientific label. It's a sign that the Earth's frozen parts, they're not static. They don't stay still. They shift. They move heat around. They store water. They shape coastlines, and they reflect sunlight. No matter what you think, they matter more than they seem to at the end of the day. And what makes this system so important and so fragile? It's all about timing. You see, it could take thousands of years for a glacier to form, but it could start shrinking in just a couple seasons. And that kind of change doesn't just affect maps. It affects all of our lives. And some towns, they were built on the idea that the ice beneath them, it would never move. That assumption no longer holds. Some scientists rely on photos from World War II to study glaciers, because those glaciers just don't exist anymore. So when we talk about the cryosphere, we're not talking about something frozen in place. We're talking about a moving part of Earth's machine. It's slow, it's steady, it's full of force. It's been doing it for thousands of years, millennia. And when it shifts, everything shifts with it. These are Interesting Things with JC.